Okay, so today we're going to start Cbse 6.4, 6.5 of applications of derivatives, where today particularly we're going to learn absolute maxima and absolute minima. So here first we will learn what is absolute maxima minima, and then local maxima minima, and then what problems on local maxima minima, which will be a 5-mark questions. Okay, now absolute maxima and absolute minima. In simple words, if you ask me what is absolute maxima and absolute minima, in a given domain, the maximum, the maximum out of all is called as the absolute maximum, and the minimum out of all is called as the absolute minimum. So there is no minimum lesser than this, and there is no maximum greater than this. So that is what we call as absolute maxima and absolute minima. But when you say local maxima and local minima, if I consider this interval, this is local maximum, this is local minimum. When you consider this interval, this is local minimum and this is local maximum. So it varies from interval to interval. Sometimes there can be two values that may give us a maximum, but then out of the y value, we'll decide which one is the highest out of it. All right, so absolute means this is the least out of all. Okay, and absolute maximum means it's the highest out of all. Now, what are the steps that we follow when we do this? Step 1, differentiate the function. So from f of x, find f dash of x. Step 2, equate f dash of x to 0. With this, you can find the critical point or the factors of f dash of 0. Okay, say you're finding x is equal to x1 and x2. Say you're finding x is equal to x1, x2. When it comes to absolute maxima and minima question, the most important part is domain will be given in the question and domain will be in closed brackets. Always domain will be in closed bracket. Let's assume the given domain is a comma b, closed brackets a comma b. So step 3 is we need to check whether x1, x2 belongs to a comma b or not. If it does not belong to a comma b, then reject it. If it belongs, then accept it. So step 4, after you accept the x, imagine x2 does not belong. Imagine x2 does not belong to a comma b. So the possible values of x is x1 and then a, b. The end values also. Now step 5, apply all this in f of x. So find f of x1, find f of a, and then find f of b. The least out of the 3 will be absolute minimum. The highest out of 3 will be absolute maximum value. The least out of this is absolute minimum value. The highest out of this is absolute maximum value. Okay, taking the 7th question, look at the question. They find the maximum value and minimum value, and they didn't tell us whether it's absolute or local in the question. If you see the first question, it was clearly said it's absolute, but here they haven't told us. But look at the interval. When the interval is in closed bracket, it's always absolute. When the interval is in open bracket or no interval given, it's always local. Now 7th one is absolute, 8th one is absolute, 10th one is absolute, 11th one is absolute, 12th one is absolute, and 29th one is absolute. Clear, guys? Now we'll move on with the these questions first. Question number 7. F of x is given. Let's find f dash of x. 12x cube 24x square plus 24x minus 48. F dash of x, I can take 12 common out. X cube minus 2x square plus 2x minus 4. Then f dash of x is equated to 0 to find the critical point. So that means 12 times x cube minus 2x square plus 2x minus 4 is equated to 0. 12 will vanish because 0 by 12 is 0. And therefore it's x cube minus 2x square plus 2x minus 4. Now, being a cubic polynomial, there will be 3 roots to this. 3 roots to this. Now, what are the possible roots? X cube coefficient is 1 and it's minus 4 here. So, product is minus 4. The possible factors of minus 4 is plus or minus 1, plus or minus 2, plus or minus 4. The possible factors of this is plus or minus 1, plus or minus 2, or plus or minus 4. Now, whether by trial and error method or by the equating coefficients, check whether plus 1 or minus 1 is the factor of this polynomial. If you can find one factor, I can divide this cubic polynomial by that, and then I can generate a quotient which will be a quadratic polynomial, and I can split the middle term for that. So first thing, I need to find at least one factor so I can proceed with long division or by synthetic division. Fine. Hope you remember the hint that I told you to check plus 1 minus 1 as a factor. If sum of all coefficients, is 0, then x minus 1 is a factor. If sum of odd term coefficient is equal to sum of even terms coefficient, then x plus 1 is a factor. This is a shortcut, okay? If you don't remember this, even if you forget, that's fine. You can substitute 1 and minus 1 and check. Now, if I go for this, here I get 1, you can see the coefficients are 1, minus 2, plus 2 and minus 4. And 1, minus 2, plus 2, minus 4. Well, that's minus 3. So it's not equal to 0, so this will not work. Then odd term and even term. What are odd? X cube is odd. X power 1 is odd. The coefficients are 1 and 2 there. So 1 plus 2. Whereas x square is even, constant is even. And minus 2 and minus 4, that's minus 6. That's not equal. 3 is not equal to minus 6. Therefore, x plus 1 is also not a factor here. So we fail in both the tests. So next we need to think about plus 2 or minus 2. Let's go for plus 2. So that means I'm going to divide x cube minus 2x square plus 2x minus 4 by x minus 2. Long division. X times x square times. So it's x cube minus 2x square. Change the sign, so this will get cancelled. 2x minus 4 will come down. Plus 2, so 2x minus 4, 0. That means x cube minus 2x square plus 2x minus 4.
You can even substitute 2 and check, ma'am.
You can do that also. But anyway you need to find the quotient, no, Bhargav? So x minus 2 into
Yes, please.
x square plus 2, right? Dividend equals to divisor into quotient plus remainder is 0. So whether I write or not, it's fine. Hence, the possible factors are x minus 2 and x square plus 2. Now, f dash of x was equated to 0. That is x minus 2 and x square plus 2 equal to 0. So we get x is equal to 2 and x square plus 2 can't be equal to 0 at any case. Therefore, x equal to 2 is the only value. What is the domain given in the question? 0 to 3, right? Let me check. Yeah, 0 to 3. So x equal to 2 belongs to closed bracket 0 comma 3. Now x will be 0, 2 and 3. Now find f of 0, f of 2 and f of 3. The largest out of the 3 is absolute maximum value. The smallest out of the 3 is absolute minimum value. Do and get me the answer for these three. Come on. So yes, we got f of 0 as 25, f of 2 as minus 39, f of 3 as 16. Minimum out of this is minus 39. So absolute minimum value is minus 39. And x is equal to 2 is absolute minima. Minima. Okay. Also, 25 is absolute maximum value and x equal to 0 is absolute maxima. I'm writing in shortcut, you don't write. Absolute maxima. Eighth question, at what point in the interval does the function attains its maximum value? So that means they want us to find the x that will generate this maximum value to us. F of x is sine 2x, x belongs, see, the question haven't told us that x belongs to 0 to 2 pi, but always the domain is for x if it is not specifically said for 2x. Always it is for x only. So x belongs to 0 to 2 pi. Solution, f dash of x is 2 cos 2x. Then f dash of x is equated to 0. So 2 cos 2x is equal to 0. That means cos 2x equal to 0. Now cos 2x is 0, that is by cos 90 degree. For all the odd multiples of 90, we get 0. Cos 90, cos 3 pi by 2, 270, cos 5 pi by 2 and so on. For all the odd multiples of 90, we get 0 for cos. But the problem is domain is x belonging to 0 to 2 pi. That means 0 is less than x, less than equal to x, less than equal to 2 pi. And we are discussing for 2x now. So let's change the domain for 2x. 0 less than equals to 2x less than equal to 4 pi. So that means literally I can go from 0 to 720 degree. 2 pi is 360, 4 pi is 720. So I can take all values of 2x that till 720. Okay, so for your sake of understanding, this is 90 degree pi by 2. This is 270 degree. This is 5 into 90, 450. And then we'll get, so 90, 270, 450 and then 7 pi by 2. So 7 into 90, 630. That's all. I cannot go beyond that because beyond that we'll cross 720. So therefore, these are the possible angles. So cos 2x is equal to this. So that means 2x is equal to pi by 2 and 3 pi by 2, comma 5 pi by 2 and 7 pi by 2. Which means, 1 second, x is equal to pi by 4, 3 pi by 4, 5 pi by 4 and 7 pi by 4. So these are the possible values of x. Now substitute all this along with 0 to 2 pi. F of 0, f of pi by 4, f of 3 pi by 4, f of 5 pi by 4, f of 7 pi by 4, and f of 2 pi. The question is sine 2x, f of x is equals to sine 2x. So when x is 0, it is sine 2 into 0. Sine 0 is 0, so answer is 0. Then it is sine 2 times pi by 4, which means sine pi by 2. Sine pi by 2 is 1. Then we have sine 2 times 3 pi by 4, which is sine 3 pi by 2. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is minus 1, sine 360 is 0. So 3 pi by 2 is minus 1. Now 5 pi by 2 sine 2 into 5 pi by 4. So that means sine 5 pi by 2, which we write it as sine 4 pi plus pi by 2. So it is sine 2 pi plus pi by 2. 360 plus theta, first quadrant. So sine pi by 2, which is also 1. And then sine 2 times 7 pi by 4. Same way you keep doing it. Sine 7 pi by 2. So sine 6 pi plus pi by 2. So sine 3 pi plus pi by 2. 180 plus theta. 3 is the half revolution, so 180 plus theta. Third quadrant minus sine pi by 2. That's minus 1. And 2 pi, obviously 0. Now what is the least out of this? The least out of this is minus 1. And the maximum out of this is 1. So it attains absolute maximum value at pi by 4, at 5 pi by 4. I think only though there we are getting 1. Yeah, at pi by 4 we are getting 1. At 5 pi by 4 we are getting 1. At all the other things we get 0. So these are the two absolute maximum values are 1, and absolute maxima is attained at pi by 4 and 3 pi by 4 and so f of x is equal to 2x cube minus 24x plus 107. X belongs to 1 by 3 and x belongs to minus 3 comma minus 1. Find the absolute maximum and minimum values. Now f dash of x is 6x square minus 24. F dash of x can be written as 6 times x square minus 4. F dash of x is equated to 0. So 6 times x square minus 4 is equated to 0. So x is equal to plus or minus 2. Now x is equal to minus 2. I'm doing case 1 now, where x is equal to minus 2 does not belong to 1 comma 3. Therefore it is rejected. Hence rejected. We reject it. So possible x values are 1, 2 and 3. Now find f of 1. F of 2 and f of 3. This is for A case. For B case, x is equal to 2 does not belong to minus 3 comma minus 1. Therefore, we reject this. So possible values of x are minus 1, minus 2 and minus 3. Now find f of minus 1, f of minus 2 and f of minus 3. With this, you can see whether which one is absolute maximum value and absolute minimum value. F of x is equal to x power 4 minus 62x square plus ax plus 9. At x equal to 1, f of x attains its maximum value. X belongs to 0 to 2, find a. Now, just think, where do I get this x from generally? I get x as 1 or any value, or any x values that I generate is from f dash of x, because f dash of x is equated to 0, and from there only we get x values. So x equal to 1 or x minus 1 is the factor of f dash of x. Generally, the x values that we get is by equating f dash of x to 0. So that means x minus 1 is a factor of f dash of x. There's no doubt about it, because from there only we get x value. Now f of x is given as x power 4 minus 62x square plus ax plus 9. So f dash of x will be 4x cube minus 124x plus a. Now when I equate f dash of x to 0 only, I get x equal to 1, because that's the place where we get x values. So that's why I stated that x minus 1 is a factor of f dash of x. Now f dash of 1 equal to 0, because I said x minus 1 is a factor of f dash of x, therefore f dash of 1 is equal to 0. F dash of 1 is 4 times 1 cube minus 124 into 1 plus a equal to 0. So that means 4 minus 124 plus a equal to 0. So minus 120 plus a equal to 0. A equals to 120. So this is the value of a for which x is equal to 1 attains its maximum value. F of x is equal to x plus sine 2x. X belongs to 0 to 2 pi. Find absolute maximum and minimum value. Question number 12. So f dash of x is equals 1 plus 2 cos 2x. F dash of x is equated to 0. 1 plus 2 cos 2x is equal to 0. So cos 2x is equals minus 1 by 2. Now cos 60 degree is 1 by 2. So I'm not going to write in degree form. I want everything in radian form, and here it's minus 1 by 2. Cos becomes negative first in the second quadrant and then in the third quadrant. Alright, so listen, cos 2x is equals to cos pi minus pi by 3. Pi by 3 is 60. Cos pi minus pi by 3. So cos 2x is equals cos 2 pi by 3. Now, this time I'm going to use the general solution type. Remember the x, I have to work that way also. Yeah, x belongs to 0 to 2 pi. So that means 0 is less than equal to x less than equal to 2 pi. And we are discussing here for 2x. So 0 less than equals to 2x less than equals to 4 pi. So that means from 0 degree till what is it, 720 again. 2 pi is 360, 4 pi is 720. 0 to 720. Now, listen, cos 2x is equal to cos 2 pi by 3. Hope you remember the general solutions of last year. If cos x is equal to cos y, then x is equal to 2n pi plus or minus y, where n belongs to integer. This was the general solution. Okay, now here x here is 2x and y here is 2 pi by 3. So therefore we get 2x is equal to 2n pi plus or minus 2 pi by 3, and n belongs to integer. Now that means x is equal to n pi plus or minus pi by 3. So this is for x. I am not leaving at 2x, I am doing for x. Because x lies between 0 to 2 pi, 2x lies between 0 to 4 pi. So I changed for x now. So all my answers should be within 0 to 360 degree. Now let's take, as I said, n belongs to integer. Let's consider n as 0. When n is 0, x is equal to 0 pi plus or minus pi by 3. So that means x is equal to plus pi by 3 or minus pi by 3. But minus pi by 3 does not belong to 0 to 2 pi. So I will reject that. I'll take x is equal to pi by 3 from this. Then I'm going for n equal to 1. N equal to 1, x is equal to pi, because it's 1 here. So pi plus or minus pi by 3. And you get x is equal to pi plus pi by 3, comma, pi minus pi by 3. So x is equal to 4 pi by 3, and here 2 pi by 3. 4 pi by 3 is 4 into 60. So what is 240? Within 0 to 2 pi. 2 into 60. 2 into 60 is what? 120. That is also between 0 to 2 pi. So I can accept both these x values. Now n equal to 2. When n is 2, x is equal to 2 pi plus or minus pi by 3. With this, I get x is equal to 2 pi plus pi by 3, comma, 2 pi minus pi by 3. So x is equal to 6, 7 pi by 3, comma, 5 pi by 3. 7 pi by 3 is 7 into 60, 420. Crosses 360 degree. So I have to reject this. 5 pi by 3, 5 into 60. So 5 6 are 30, 300. So I can accept this. So x is equal to 5 pi by 3 is accepted. And thereafter you won't get, because it will cross 2 pi. Therefore, the possible values of x are pi by 3, 4 pi by 3, 2 pi by 3, and 5 pi by 3. Along with that, we have 0 to pi, the end value, 0 to 2 pi, the end values. So I'm not scrolling, I'm doing it here in the side. So we got x 0 in the domain, and then we found pi by 3, we found 4 pi by 3, we found 2 pi by 3, and we found 5 pi by 3. With that, we have 2 pi. 2 pi is the end value. 0 and 2 pi are the end values. The rest of all are x values that we found. Now, find f of 0, f of pi by 3, f of 4 pi by 3, f of 2 pi by 3, f of 5 pi by 3, and last f of 2 pi. What is the question? X plus sine 2x, I guess. So start applying the values one by one. Yeah, question is x plus sine 2x here. F of x is equals x plus sine 2x. So when it is 0, it is 0 plus sine 2 into 0. That means 0 plus 0, 0. Next one, pi by 3. So pi by 3 plus sine 2 times pi by 3. So pi by 3. How do I deal with pi by 3? Here I'll consider pi as 22 by 7. So this will be 22 by 21 plus sine 2 pi by 3 is what? Sine pi minus pi by 3. So you get 22 by 21 plus sine 180 minus theta, second quadrant. So sine pi by 3. So 22 by 21 sine pi by 3 is sine 60. Sine 60 is root 3 by 2. We need to get and see the answer for that. Likewise, we do it for 4 pi by 3. Maybe I'll do it down. So f of 4 pi by 3, which is 4 pi by 3 uh, plus sine 2 times 4 pi by 3. 4 pi by 3 is 4 into 22 by 21. 21. Yeah, 22 by 21 plus sine, yeah, 2 into 2 pi by 3, 4 pi by 3. Yeah, so it's 8 pi by 3. 8 pi by 3. Break it. And keep doing this. Whenever you get an angle, you substitute and you break it. So if it's 8 pi by 3, I can write this as 6 pi, what is it? 9 pi minus pi by 3. 9 pi minus pi whole divided by 3. And then you can get an answer for this. So 4 into 22 by 21 by sine of 8. I'll write this as 9 pi plus pi whole divided by 3. So sine of 3 pi plus pi by 3, which is 180 plus theta. So 4 into 22 by 21 by sine 180 plus theta is minus sine theta. So we get minus sine pi by 3. So substitute root 3 by 2. So this way you keep doing for all the values. Now find out the least out of this and maximum out of this. I think maximum will be at 2 pi and the smaller, the least will be at 0. So get the answer now. So 8 pi is 9 pi minus pi by 3. Earlier I wrote 9 pi plus pi by 3. So it's 9 pi minus pi by 3. So that's 3 pi minus pi by 3. So 3 is the revolution. So we'll ignore. 180 minus theta, second quadrant, sine is positive. So sine pi by 3. So this will give us 88 by 21 plus 1 by, sine root 3 by 2 is 60 degree. That's root 3 by 2. And then f of 2 pi by 3. So that's 2 pi by 3 plus sine 2 times 2 pi by 3. So 2 pi by 3 plus sine 4 pi by 3. 2 into 22 by 21 plus sine 4 pi, that is 6 pi minus 2 pi, or 3 pi plus pi, that's also fine. So 3 pi plus pi by 3. So 44 by 21 plus sine pi plus pi by 3. 180 plus theta. 44 by 21 minus sine pi by 3. Sine pi 5 pi by 3, it's 5 pi by 3, 2 times x, yeah, 2x, yes, plus sine 2 times 5 pi by 3. So 5 pi by 3 plus sine 10 pi by 3. So 5 pi by 3 plus sine 9 pi plus pi by 3. So 5 into 22 by 21 plus sine 3 pi plus pi by 3. So get an answer. And then so 2 pi plus sine 2 times 2 pi. 2 into 22 by 7 plus sine 4 pi. Sine 4 pi is 0. So 44 by 7. Maybe this is the maximum out of all. and at 0 only you get the minimum value. So this is how we find the maximum minimum of this.